The image came down from JWST in the middle of a quiet workday, and the first people to see it knew immediately that something was wrong. Not wrong as in broken, wrong as in the universe was not supposed to look like this. Yet. XLSSC 122, a galaxy cluster sitting almost 12 billion light-years away, in a part of cosmic history where clusters are not supposed to be finished. And this one is finished. Its galaxies are already old. Its gas is already hot. Its stars have already stopped forming. The press releases called it a record. The papers, read carefully, called it something else. Because if XLSSC 122 is real, and it is, then the story we tell about how the universe grew up has a hole in it, and JWST is standing over that hole, taking pictures. That is the part they did not put in the headline. Before we go further, tell me where you are watching from, and whether you have heard this cluster called an anomaly or a confirmation. Because the difference between those two words is the entire story. Here is what you need to understand about XLSSC 122. It is not a young thing. Its galaxies are dominated by old stars, which in cosmology has a very specific meaning. It means star formation shut down billions of years before we are seeing it. The intracluster medium, the enormously hot gas that fills the space between the galaxies, is already enriched with heavy elements. That means generations of stars have already lived, died, and seeded the environment with metals. And the whole system is already gravitationally bound. It is not still assembling. It is done. Now hold that in your head and add one more fact. The light we are seeing left this cluster when the universe was about 3.4 billion years old. Not 13.8, 3.4. And the stars inside it are already at least 2 billion years old at that moment. Which means star formation started when the universe was barely over 1 billion years old and had already stopped by the time we are looking. A finished city in a universe that was supposed to still be laying pipe. This is the thesis. JWST did not confirm the standard picture at this distance. It broke it. And it is not the only object doing so.
XLSSC 122 is one of the cleanest examples of a pattern that is now stacking up across independent programs. And the pattern points in a direction the public conversation has not caught up with yet. The comfortable version says, "Interesting anomaly." The harder reading says, "Our timeline of cosmic history is provisional, and the confidence in the summary is higher than the model currently earns." That is where this story is going. Here is the story you have almost certainly been told. JWST is the most powerful space telescope humanity has ever built. It launched, it worked, it looked farther than Hubble, and it kept finding things that confirm how impressive the universe is. XLSSC 122, in that story, is a distance record. A beautiful, deep image of an ancient galaxy cluster. Proof that the instrument works. Proof that science is winning. That version is not false. It is just softened. Because if you read the actual papers and read the language the researchers use in the abstracts, the tone shifts. Words like unexpected, mature, quenched, in tension with. These are not celebration words. These are pressure words. They are the vocabulary scientists reach for when the data is doing something the model did not predict. Here is the part that matters. JWST did not discover XLSSC 122. It convicted it. The cluster was first flagged back in 2011 by XMM Newton, an X-ray telescope, which picked up a signal that was already too bright at that distance to fit the standard timeline of structure formation. Follow-up work with Hubble and ground-based spectroscopy sharpened the concern. By the time JWST turned its NIR spec instrument on this system in 2023 and 2024, the question was not whether the cluster was there. The question was how bad the problem was. Now think about how that story got compressed for the public. Distance records are impressive without being threatening. So the coverage led with distance. Maturity at that distance is the actually threatening part. So the coverage buried maturity. The average viewer walked away thinking JWST had confirmed the expected picture. The working cosmologist walked away with a slightly worse headache than before. This is not a conspiracy. This is a translation gap. Press offices exist to translate hedged academic language into confident public language. In tension with the standard model becomes reveals surprising details. Reveals surprising details becomes a triumph.
And the triumph becomes the entire public memory of the event. Here is the blunt version. The official story is not lying, it is smoothing. And smoothed stories do not produce public urgency about a scientific problem that deserves it. The reassuring frame only holds together if you ignore three things. You have to ignore the age of the stellar populations. You have to ignore the temperature of the intracluster gas. And you have to ignore the fact that this cluster is not the only object of its kind. Ignore all three, and JWST is a success story. Include all three, and JWST is delivering a warning. So how does the universe even build a cluster like this? And why is it a physical problem for one to be finished at all this early? Galaxy clusters are the largest gravitationally bound structures in the universe. Nothing bigger holds itself together. They contain thousands of galaxies, oceans of hot gas, and enormous halos of dark matter. And in the standard model of cosmology, they are supposed to be the last thing to finish assembling, not the first. The recipe is slow. Dark matter collapses first, pulling itself into halos through pure gravity. Gas falls into those halos, cools, and forms the first galaxies. Those galaxies then take billions of years to drift toward each other, merge, and pile up into groups. Groups then merge into clusters. Only after enough mass has piled up does the intracluster medium heat to the temperatures that make clusters detectable in X-rays. It is a sequence. You do not skip steps. Think of it like a city. You do not get skyscrapers before you get streets. You do not get a fully lit downtown before the neighborhoods finish being built. Structure needs time, and cosmic structure needs a lot of it. XLSSC 122 is a fully lit downtown in a universe that was still supposed to be laying pipe. Here is where the numbers stop being abstract. The cluster sits at a redshift of about 1.98. That translates to a light travel time of roughly 10.4 billion years, which means we are seeing it as it was when the universe was about 3.4 billion years old. In that moment, the stars inside its galaxies are already at least 2 billion years old. Do the subtraction. Star formation started when the universe was barely 1 to 1.5 billion years old, and had already ended by the time the light we are now receiving left the cluster. Read that again. The stars finished forming, aged, and shut down.
In a window that the standard model says was mostly meant for building the first galaxies, not retiring them. The Lambda CDM model, the current standard framework of cosmology, permits clusters this early only under aggressive assumptions about how quickly dark matter clumped in the early universe. Those assumptions used to sit at the edge of the allowed range. XLSSC 122 pushes on that edge. And the Planck satellite, which measured the cosmic microwave background with extraordinary precision, is the instrument that set the timeline this cluster is straining. Here is the part that should bother you. The problem is not in the observation. JWST is not misreading the light. The problem is in the model that told us how much time this cluster should have had. And when the observation and the model disagree at this level, one of them is wrong. The weak point, in other words, is not the telescope, it is the theory. There is a word that keeps appearing in the JWST papers about this cluster: quenched. It sounds technical, and it is, but it carries a heavy meaning. A quenched galaxy is a galaxy that has stopped forming stars. It has run out of the cold gas it needs, or something has heated that gas, or something has stripped it away, and the star-making process has shut down. The galaxy is still there, but it is not making anything new. It is drifting through the rest of cosmic history as a red, aging, closed system. The galaxies inside XLSSC 122 are quenched, multiple of them, confirmed by JWST's NIR spectra, which show the fingerprint of old stellar populations, a specific spectral feature called the 4,000 angstrom break that only shows up when a galaxy's stars have had time to age. That fingerprint should not be that strong, at that distance, in that many galaxies at once. Here is why this matters more than the discovery itself. Quenching requires a mechanism. Galaxies do not just decide to stop. Something has to intervene. The known mechanisms are things like feedback from a supermassive black hole heating the gas, ram pressure stripping as the galaxy moves through a dense environment, or strangulation as the supply of fresh gas is cut off. Every one of these mechanisms takes time, and every one of them requires a certain level of environmental maturity to work efficiently. In an environment this mature this early, either the mechanisms ran faster than we thought was possible, or something else did the work that our models do not account for. Neither option is small. Let that sit for a second. Red and dead sounds poetic in a press release. In the model, it means the star formation clock inside these galaxies ran out before it should have started ticking. It is the equivalent of finding a fossilized adult in a layer of rock dated to before the species evolved. You do not shrug at that. You go back and check the rock. The comfortable framing is that our understanding of quenching is incomplete, but essentially correct, and XLSSC 122 just pushes the timeline a bit. The harder reading is that the fragility is not in one process, but in the whole scaffolding, because every downstream prediction, every later structure, every later star, every later planet inherits from these early rates. If the early rates are wrong, the inheritance is wrong. And here is the mini hook. This is not the only object doing this. JWST has been quietly stacking up similar cases in different corners of the early universe, in different types of systems. XLSSC 122 is not the anomaly. It is the pattern. One anomaly is a curiosity. Two is a coincidence. What JWST has been finding, since it opened its eyes, is a series. In its first year of science operations, JWST flagged galaxies at extreme redshifts that appeared far more massive than early universe models allowed. The CEERS and JADES surveys turned up systems that, if their inferred masses hold up, would require a significant fraction of the available baryonic matter at that epoch to already be locked into stars. The public headline said early galaxies were bigger than expected. The papers said the mass function at those redshifts is in tension with lambda CDM. Then came the supermassive black holes. JWST found them too, and it found them earlier than the standard growth models permit. Black holes that had somehow reached hundreds of millions of solar masses when the universe was less than 1 billion years old. Growing that fast, from that little, in that short a window, is not a small problem. It is a problem that sits right next to the galaxy assembly problem, and both are asking the same question. How did the early universe build so much, so fast? Now add XLSSC 122 to that stack. Not massive early galaxies, not oversized early black holes. A fully assembled, chemically enriched, quenched cluster. 3 different types of anomaly, 3 different classes of object, all pointing in the same direction. The early universe was doing more work faster than the model predicted. This is scale rupture. The intuitive expectation is that 1 anomaly is easy to absorb, 2 is manageable, 3 is still tolerable. But cosmological models do not scale their tolerance linearly. Each new anomaly puts pressure on the same underlying parameters, and at some threshold, the outliers stop being outliers. They become the data. Hubble had surprises too. The deep field images in the 90s revealed more galaxies than expected in dark patches of sky. The community absorbed those surprises by tweaking parameters, refining the model, adjusting the assumptions. But JWST is producing surprises faster than tweaks can absorb them. That is a different regime. Here is the historical comparison that should sit with you. The last time cosmology faced pressure this consistent, from this many independent directions, it led to the introduction of dark energy in the late 1990s. An entire new component of the universe added because the observations demanded it. Nobody wanted it. Nobody predicted it cleanly. The data forced it in. The story is no longer that JWST found a weird cluster. The story is that JWST keeps finding the same weirdness, dressed in different clothes, and XLSSC 122 is one of the cleanest examples. So what does that mean for us? For our own timeline? Every model of how we got here inherits from the early universe. Every calculation of when the first stars lit up, when the first galaxies stabilized, when the first heavy elements were forged and scattered, when the first rocky planets could plausibly form, all of it sits on top of the early universe formation rate. If that rate is wrong, every date downstream of it has a soft flaw. Think about what you are made of. The carbon in your cells, the oxygen in your lungs, the iron in your blood. None of it was here at the beginning. All of it was forged inside stars, and scattered when those stars died, and gathered again by gravity into new stars and new planets. That process has a start time and a rhythm and a pace. And the start time is exactly what XLSSC 122 is throwing into question. Read that slowly. The atoms in your body have a timeline. That timeline is not fixed by revelation. It is fixed by cosmology. And cosmology is currently arguing with itself. Here is where the numbers sharpen into meaning. The universe is 13.8 billion years old, according to the current best fit.
Earth is 4.5 billion years old. The window in between, roughly 9.3 billion years, is where we assumed we understood the sequence. First stars, first galaxies, first metals, first planets, first oceans, first life. A story we have been telling with increasing confidence. But if clusters were assembling and quenching 2 billion years earlier than the model expected, then the enrichment of the universe with heavy elements also began earlier, which means the earliest possible window for rocky planets shifts, which means the earliest possible window for chemistry that could support life shifts, which means one of the quiet assumptions of modern astrobiology, that we are near the front edge of a young universe
that had barely finished cooking the ingredients for life may not hold in the way we thought. This is the humanization pivot. XLSSC 122 is not just a dot on a redshift chart. It is a data point in the argument about when we could have first appeared, and when others could have appeared before us. There is a version of this story where we are early. There is a version where we are not. The difference between those versions runs through this cluster and every anomaly like it. Let that sit for a second. A galaxy cluster almost 12 billion light-years away is quietly rewriting the sentence you use to answer the question, "Are we alone?" And it is not the only measurement doing so. Cosmology already had a crisis before JWST turned its mirror. It is called the Hubble tension, and it has been growing, not shrinking, for years. Here is the short version. There are two independent ways to measure how fast the universe is expanding right now. The first uses the cosmic microwave background, the leftover light from the early universe, measured most precisely by the Planck satellite. It gives a number. The second uses supernovae and other standard candles in the local universe, calibrated by teams like SH0ES. It gives a different number. The two disagree, and the gap is not closing. Better data has made it worse, not better. For a while, the community assumed the disagreement would resolve. Somebody was making a systematic error, and once the error was found, the numbers would meet in the middle. That has not happened. The measurements keep getting cleaner, the disagreement keeps holding. And that is the definition of a real tension in the model, not a data problem. Now watch what happens when you drop XLSSC 122 and its cousins on top of that.
One of the proposed explanations for the Hubble tension
Is early dark energy. A component of the universe, active in the first few 100,000 years, that briefly changed the expansion rate before fading away. If that idea is right, it would also change how quickly structure could grow in the early universe, which is exactly the direction JWST's early anomalies are pointing. Read that connection carefully. Two problems in two different parts of cosmology, measured with two completely different techniques, both point toward the same possible fix. That is not a coincidence. That is a hint. The historical comparison is worth stating. In the late 19th century, physicists were told the model of the physical world was almost complete. Small residual problems remained. The problems turned out to be relativity and quantum mechanics. The whole framework had to be rewritten. We are not necessarily there, but we are in a familiar posture. Small residual problems, in multiple independent places, refusing to go away. Here is the blunt version. The Hubble tension by itself is embarrassing. XLSSC 122 by itself is embarrassing. Together, they are pressure, and the community is starting to talk about them as connected, not separate. So why is the public still hearing the confident version? Why are the press releases still leading with success when the working literature is leading with tension? There is a structural reason for that, and it is worth walking through carefully. There is a filter between the paper and the viewer, and it is not conspiracy. It is incentive. Space agencies fund telescopes by demonstrating success. That is how the money keeps flowing, how the next mission gets approved, how the careers behind the instrument survive the political cycle. When JWST delivers an image of an ancient galaxy cluster, the institutional pressure is to lead with the win. The distance is a win. The clarity is a win. The instrument is a win. And all of that is true. The tension inside the science is also true. But tension does not fit as cleanly on a press release. Press offices are staffed by translators. Their job is to take hedged academic language and turn it into confident public language. In tension with the standard model becomes,
reveals surprising details about the early universe, challenges current formation timelines, offers new insights. Every softening is defensible on its own.
The cumulative effect is a public that believes cosmology is settled, while the working cosmologists know it is not. Here is the fairness clause, and it matters. This is not accusing scientists of hiding anything. The papers are public. The tension is stated plainly in the abstracts. The community is arguing about it in journals, at conferences, in preprint servers. Nothing is being suppressed. What is being smoothed is the translation layer between the paper and the person who reads about it over coffee. That smoothing has a cost. It creates a gap between what people think science says and what science actually says. And when the gap is wide enough, the eventual correction, if it comes, feels like a shock, a rewriting, a crisis, when in fact it was visible in the literature all along, just not in the headlines. Compare the abstracts of the XLSSC 122 papers from the original XMM Newton detection to the JWST spectroscopic follow-ups with the language used in the accompanying ESA and NASA releases. The academic language is careful, hedged, and tension-aware. The public language is celebratory, confident, and clean. Neither version is wrong, but only one of them contains the warning. Read between the lines. The story is not being suppressed. It is being made comfortable. And comfortable stories do not produce the public urgency that scientific tension deserves. Now think about what that means at scale. Not just for XLSSC 122, for every anomaly JWST has flagged, for the Hubble tension, for the whole quiet renegotiation happening in cosmology right now. The biggest reading of what this cluster is telling us is the one nobody is putting in the headline. Here is the reclassification. XLSSC 122 stops being a distant object. It becomes a data point in a much larger argument, and the argument is about whether we understand time in the universe at all. The age of the universe is quoted as 13.8 billion years, with a precision that sounds impressive. But that number is not measured directly. It is derived. It comes from fitting the lambda CDM model to the cosmic microwave background, plus a set of assumptions about the components of the universe and how they have evolved. Change the model, and the derived age changes. Some proposed modifications would make the universe slightly older. Some would keep the age, but change how quickly structure could form inside it. Either way, the confidence in the quoted number is higher than the underlying framework currently earns. Read that carefully. It is not saying the universe is a different age than we think. It is saying that the number is a fit, not a measurement, and the fit is under strain. The strain comes from multiple directions at once: the Hubble tension, the early universe mass anomalies, the premature supermassive black holes. XLSSC 122 and its fully quenched galaxies. Each pointing at a different piece of the model, each individually absorbable, together forming a picture the community is starting to take seriously as a signal that lambda CDM may be incomplete in a way that matters. Here is the fairness clause again. This is not saying the Big Bang did not happen. The evidence for the hot early universe is overwhelming. The cosmic microwave background is real. The abundances of light elements match nucleosynthesis predictions with extraordinary precision. The large-scale structure of the universe fits the broad model. What is under question is not the framework's foundation. It is the finer details of what happened in the early phase and how quickly and driven by what. But those finer details are where our story of ourselves lives. When the first galaxies stabilized, when the first metals appeared, when the first planets could form, when the first chemistry that could support life became possible. All of that lives in the finer details, and the finer details are the part currently under revision. Every previous rewriting of cosmic history was preceded by exactly this kind of accumulating small anomaly. Galactic recession before Hubble, black-body radiation before quantum mechanics, supernova brightness before dark energy. The pattern is not new. What is new is the pace at which JWST is producing it. Which leaves us with one honest question, and it deserves to be asked directly. How sure are we of the picture we have been shown? Here is the verdict. XLSSC 122 is not proof that cosmology is broken. It is proof that cosmology is unfinished. And the size of what is unfinished is larger than the public conversation admits. Consolidate the evidence. A fully formed, chemically enriched, quenched galaxy cluster at redshift 1.98, confirmed by JWST spectroscopy. A pattern of similar early universe anomalies across independent JWST programs, in independent classes of object. A persistent Hubble tension that has grown, not shrunk, with better data.
A growing willingness in the working literature to consider modifications to the standard model, including early dark energy and revised structure formation physics. None of this is fringe. All of it is in the mainstream journals. The last comfortable illusion, the one that says science will figure it out, and therefore the current picture must be essentially right, needs to be stripped. Science will figure it out, that is true, but it does not mean the current picture is right, and it does not mean the answer, when it arrives, will be small. Return to the opening image. The photograph of XLSSC 122 that came down from JWST is beautiful. What it depicts is a system that either broke the rules of the standard model or is quietly telling us the rules were wrong. Both readings are serious. Neither reading is what the headline said. Here is the fairness clause, final version. This is not saying the Big Bang did not happen. It is not saying cosmologists are incompetent. It is not saying JWST is misleading anyone. It is saying that the universe the data is describing is not the universe the summary is describing. And the gap between those two is where the real story lives. And here, only here, at the end, a narrow hope is allowed. This is what discovery actually looks like. Not confirmation, confrontation. JWST is doing exactly the job it was built for. The uncomfortable part is that its job includes showing us where we were wrong. That is not failure. That is progress in its harder form. But do not let the hope soften the recognition. The light from XLSSC 122 left when the universe was young, and by the time it reached JWST, it was carrying a message. Our story of what young even means may need to be rewritten. Not the story of whether the universe began, the story of how it grew up, and by extension, the story of how we did. That is the message in the image.